When analyzing data, we typically look at the numbers associated with the sport. But what if we can quantify the psychological aspects of sports? The truth is, coaches in the NBA do not know how to use timeouts. If we can minimize psychological aspects towards timeouts, we can minimize unnecessary timeouts.
Timeouts are used for a variety of reasons, but the momentum varies the most.
So momentum can be separated into two concepts. We have psychological momentum, which is the human element that coaches use to manage a game with timeouts. And we have the statistical momentum, where modern data science supports the idea multiple repeated successes could influence the next one.
Model A analyzes patterns of momentum based on psychological aspects. We can use the linear regression model to put patterns of plays against the outcome of a game to determine if certain patterns are associated with a win or loss. The model then uses data to create scenarios of when to use the timeout and learns based on real-life examples and their outcomes.
We also build a statistical model that evaluates the game state before timeout, like identifying things like opponent runs, then comparing to actually what happens after the timeout. We leverage XGBoost to uncover patterns that show when a timeout most likely shifts momentum.
Our hybrid ensemble model dual feeds conclusions from our two models and uses a weighted algorithm to deduce a result leveraging the advantages and limitations of both psychological and a statistical outlook.
Now, looking at the demo, we have the live feed, which shows the points for each team, and we also have each and every real-time play. We have both of the models being depicted. So for Model A, we have the favorability for Team 1 being depicted with a positive value and vice versa. For the streak, we have that being weighted in Model B. So we have the current streak being highlighted in purple for the actual bar that would be represented for the actual win percentage. And using these two models, we can accurately determine, based on our hybrid ensemble algorithm, which the actual timeout decision is going to be.